On April 27th, an unprecedented natural disaster unfolded before our eyes as dozens of tornadoes raked the state. Many were violent, long-track tornadoes. Not since 1925 has the loss of life been so great in a single day by tornadoes in the United States. In a blink of an eye, well-constructed homes were turned to rubble, trees were stripped of their bark, and churches and businesses were taken to the ground. The National Weather Service has a mandate to protect life and property, and we have worked diligently to do so for more than a century. Technology has increased greatly in recent decades, with Doppler radar technology allowing forecasters to view the wind flow and rotation within storms, high-resolution satellite imagery that shows fronts and other features critical to tornado development, and computer models that better predict the evolution of weather in the upcoming days. In the days preceding what is now referred to as the super outbreak, meteorologists became increasingly concerned about this being the big one. Sadly, even their dire predictions were well below reality. This event will go down as the most tragic tornado outbreak in modern times, and will likely be the benchmark upon which all future research is constructed. To prepare, the National Weather Service office in Huntsville started briefing emergency managers, first responders, and local media more than 48 hours in advance that this would be a major outbreak. In short, we knew it was coming. When I woke up at 4 o'clock on Wednesday morning, I looked at the radar on my phone to see storms approaching from the south and the west, and knew that it was potentially even worse than I could have imagined. If tornadoes were on the ground at 4 a.m., what would the rest of the day hold? By the time I arrived at work around 5 a.m., the initial damage reports were already rolling in. No matter how long you've done this job or how many times you've been in this position, nothing prepares you for some of the calls you have to take or some of the things that you see. As the first wave rolled through and the next wave began to move in from Mississippi during the mid-morning, it was obvious there would be no breaks for the area that day. Some locations were hit multiple times, the same houses damaged in the morning and wiped clean in the afternoon. I talked to one man who was called to his home in East Limestone after the morning storms and was busy tarping his house when the sirens blew again. A few minutes later, he and his wife rode out the tornado in their shower, landing on top of a neighbor's pile of rubble. Then came the big ones. The final and most intense group of supercells began to organize across Mississippi and western Alabama. We all had a sinking feeling. By early to mid-afternoon, conditions were optimal for long-track killer tornadoes. Every storm on the radar was showing signs of rotation, but soon the situation would get even more dire. First it was the Coleman storm. Confidence was high that a tornado was occurring, and then there it was on the local Skycam. But to top it all off, there was a storm moving up through Hackleburg and toward Phil Campbell, with winds of at least 200 miles per hour. Forecasters often refer to a hook echo as a definitive sign of a tornado. Well, this storm had something more, a well-defined debris signature, where the radar was not picking up rain or hail, but was actually picking up large chunks of debris like roofs, plywood, or even trees. That's when you know that things are bad. Let's be clear, we all are professionals and we all have a job to do. However, as the storm rolled through Mount Hope and then toward Tanner, we were all visibly shaken. Damage reports were slow to roll in from a few locations, and we knew why. It wasn't because this wasn't a damaging tornado, but because there was no one left to report the damage. In our gut, we knew that there were mass injuries and very likely a large number of fatalities. We can only pray that our warnings, updates, and diligent work could prevent this from being a complete catastrophe. In the days that followed the destruction, our staff worked many 16-plus hour days, surveying damage, providing incident support to first responders, and just being there for the community. Our staff was fortunate as we had little damage as a whole, and no injuries or loss of life. As I traveled our area from Tanner to Harvest, to Huntland to Higdon, to Oak Grove to Phil Campbell, I gained a greater sense of pride in our community, with people helping strangers, stopping to hand out food, or just stopping to see if you need a ride to a shelter. The scenes of destruction out there are sobering, even for a seasoned meteorologist, and someone who has been on nearly 50 storm surveys. Seeing a house with an anchor bolting completely obliterated in Oak Grove was sobering. His neighbor was still looking for a Ford Crown Victoria that was completely taken away. Seeing entire neighborhoods in northwest Madison County brought to the ground was horrendous. The scene along Rosie Road in Tanner was gut-wrenching, and just walking down Brown Street in Phil Campbell too much to bear. The storm was so powerful there that it pulled the pavement out of the ground. Just think about the force involved there for a minute. But that's a mere sampling of the catastrophic destruction that stretches as far as the eye can see. But the stories of survival are also uplifting. I think of the many people who praised the warning system for saving their lives, and the many that showed us their storm shelters and where they went to ride out the storm. We found a family of 4 in Higdon who somehow were left untouched in their house when everything else was swept clean around them. There wasn't even any rubble left, and the propane tank was lofted directly over their heads, just missing them by a few feet. Those are little pieces of joy and optimism in a large sea of despair. Our community will recover. We will move forward. And the National Weather Service will continue to work tirelessly to protect our citizenry when the next threat approaches.
They can't possibly have an understanding of the amount of preparation that goes into it, how difficult it is to anticipate and forecast all the things that have to come together for an event like this, let alone a small-scale event, but something of this magnitude. How infrequently something like this happens. And it's just very difficult to understand what all goes into the process.
Before the event, I started forecasting on Saturday, so 4 days before the event. And I was in charge of the 7-day forecast. It didn't seem realistic that our forecast 4 days out was going to be this bad and actually verify. And so we had this idea that we're going to have some bad storms on Wednesday, but I don't think we had a full appreciation on really how well the models were handling that forecast out 4 days.
Things I remember most were, hashing out the forecast and trying to figure out what was going to happen. It looked even then like there might be a couple of waves of activity. We'd had a situation on April 15th where it looked like we had a fairly high likelihood of severe weather in the region, and our area northern Alabama was pretty much spared because of there was a lot of cloud cover and rain fall that morning, which hindered our instability. So central Alabama got a wall up that day, with a lot of severe weather. So I remember sitting on the forecast desk and trying to discern whether or not that kind of a thing was going to happen again. I didn't think so. I was more inclined to think that we were going to have a severe weather outbreak.
It was quite eye-opening to see something like that consistently being shown by the models, and then for it to actually play out.
We will compare what the models are predicting to how previous events have been set up. And I remember seeing all these big severe weather outbreaks being hit upon by the analogs, that this is just like these other events. We will fully brief our emergency managers. We'll have conference calls basically on an 800 megahertz radio system. And we will prepare a PowerPoint presentation and show them, this is kind of what we're expecting with the forecast. Here's the timing, here's the threats, here's our confidence level. So I know we started communicating with our emergency managers and started preparing briefings. I think we did our first full briefing on Monday with our emergency managers, really giving them a heads up that this is going to be a bad day on Wednesday. We've got everything lining up. There's going to be some problems. It's going to be a long day. We could have multiple rounds of storms.
This was the middle of the week. It was, we were leading up to it on a Monday and Tuesday. The event was going to occur on a Wednesday. So obviously there was a lot of concerns about school closures. We had gone through a winter where we had a very significant winter storm that occurred on the 10th of January, and many areas were out of school for a long period of time. So folks were trying to, the school superintendents were trying to, have school as many days as possible. So it was really, they were trying to balance the situation where we don't have any more snow days or we don't have any more weather days versus, okay, can we get some school in that day versus when are the storms going to get in there?
We did conduct routine briefings and were mainly preparing a staffing plan for the office. We were becoming increasingly concerned as we grew closer to the event that we would be experiencing the brunt of the tornado outbreak in our area. Real sinking feeling came that early in the morning on April the 27th when we were placed in a high risk of severe weather by the Storm Prediction Center.
We had 3 waves of storms, one that moved through in the early morning hours, and then one that moved through in the midday where there was really maybe like an hour break. And then the biggest of the storms, the biggest of the storm events were the supercells in the afternoon that lingered until maybe 9 or 10 o'clock in the evening. There wasn't even a time period where someone wasn't having to watch radar, wasn't having to be alert of what was going on. So that was just, from a fatigue standpoint, that was significant.
Even not doing official warnings and statements, this was probably the highest impact event I've ever worked in my career. I think the second highest impact event, at least the highest one before then, I was working forecast shift when Hurricane Katrina came ashore, and when it knocked out the communications junction in New Orleans, and then we had to back up Jackson. That's when it really became busy here.
I was working an evening shift on the night before, in other words, on Tuesday, April the 26th, and was held over at the office until about 6 o'clock in the morning on April the 27th because of the first wave of tornadic thunderstorms that moved into the area during the middle of the night.
The first wave came in, I believe it was about 4 o'clock in the morning. We had already seen that the previous storms that were in Mississippi actually were supercells. It was already transitioning to a line as the supercells were kind of merging into a line. The mode of QLCS does make it a lot more difficult to warn, given the small, very small, and very quick spin-up tornadoes. So we just transitioned that mode and started looking in the various places along the line to see where some of those mesovortices could actually develop. As that mesoscale vortex moved into Marshall County and it started dropping all kinds of tornadoes, we were looking at we were able to see at least 2 or 3 mesoscale vortexes, but it was actually producing more than that. I was describing where that one of those vortexes were, and then one of our EMAs was actually saying that's exactly where we're having damage right now. It's exactly where we're having damage here. It's exactly where we're having damage here. So it was all over the place. The first wave we had 2 radar operators, me initially, and then we did have somebody else come in, or that was on the midnight shift that actually did that. He transitioned to warning operations as well, and we had an additional individual that was from the evening shift actually staying over. And then we called someone in early from the day shift, so I believe we had at least 4, if not 5 people.
Of course, we knew that was just the first part of the day. We certainly didn't know what was going to unfold exactly from that point forward.
I got really worried about the rest of the day of, if it's already this bad this early, how bad is it really going to be this afternoon? I was scheduled to come in at 7, I believe, and woke up early because there was already storms rolling in. I decided to come in early. I think I got here 6:15, 6:30, and immediately got briefed on the situation, sat down, started getting spun up on radar.
Well, I got here right around 7 o'clock that morning, which is normal time, and already at that time things were really starting to heat up.
Chris White was our other radar operator that day, and he came in early for his shift, and we both basically took it from there once we relieved the midnight crew.
I'm the information technology officer, so I'm mostly just deal with developing custom software, doing administrative tasks, making sure the computers are running properly, and then trying to get unique data sets and science into the office. But during the event, of course, you just help out where you can, and just jumped in at the communicator, even though I don't think I'd ever served as a communicator before. After I did it for a couple minutes, I was kind of in the groove. It's one of those situations where you look up and it's been 6 hours since you've gone to the bathroom. You don't even notice, like, the change of time, but it was really rapid fire for a while there during the event. As soon as you got done with announcing a warning, there was another one coming out. There were 5 phone calls that came in, and you got storm reports, and then you were calling various people trying to get reports. And
Primarily went around and surveyed to make sure everything was up and running, and then helped out where I could, answering the telephone for local storm reports. The equipment was up and running. I'm basically have nothing to do. So what I did during that time frame was basically tend to whoever needed something, coffee, water, whatever. I became the office gopher.
I distinctly remember at one point asking Brian Burgess, who's our electronics technician, asking him if I could get a cup of water, because I couldn't get up from my workstation. There's no time to leave your desk. And I asked him for some water, and I just remember issuing warnings and all of a sudden looking down, and there was a cup of water right in front of me.
Because everybody seemed to be almost in a zone, if you will, doing their job. There was so much going on, you didn't have time to think about it or worry about it. It was just, you were so focused on doing your share that it was hard to compare to anything else.
I distinctly remember the Coleman tornado in the afternoon, because that was the first of the big ones in the afternoon. And Chris and I we had streaming in between our workstations. We had one of the Birmingham stations that had a Skycam that actually covered the tornado.
We had our TV monitors on for situational awareness, and to see a tornado that was, I guess it was fed from the Birmingham stations, seeing the one that was headed toward Coleman, and it said, I have a live tornado that we put a warning out on. That was the first time I've seen a tornado really verified like that. The sad thing about it, we knew it was heading toward a populated area. It gives you kind of an unsettled feeling inside to see that happening. It's one thing to see a big tornado out there in the middle of the Great Plains, but if it's going through a populated area, it's another thing.
And that's when we decided to issue our first tornado emergency of the day.
We're making decisions based on radar data, which is very good. I mean, we use very good science judgment to make our warning decisions, and we use very good spotter information from our Skywarn network to add to that. But this was one of those days where we had the added value of visually seeing on television, on webcams, the tornadoes unfolding before our very eyes.
After that, I remember helping Chris watch storms that were coming into our forecast area from the Memphis forecast area and Jackson, like storms coming in from Mississippi. And I remember watching this storm as it approached this little town of Hackleburg. And I saw it produce a strong hook and a debris ball. And I remember thinking, whatever was in Hackleburg is no longer in Hackleburg. Seeing a debris ball of that magnitude in our area it's just a feeling of dread.
The tornado at one point was just very large. I mean, it was a mile wide, and so these people said they didn't even know what they were looking at. They just thought it was a low, big, dark cloud. They just normally don't get, wedge tornadoes here in northern Alabama. It's a pretty rare occurrence.
That was the first time in my life that I remember saying on the radio, violent, deadly, long-track tornadoes are heading towards Tennessee Valley, and everyone needs to take shelter and be prepared. These things are coming. There's no way around it.
On that particular day, as one of the storms that had a confirmed tornado was approaching the building and was on a trajectory to get near the building, I made the decision to evacuate the operations area because we have nothing but glass in our west-facing windows.
The fact that we have the west-facing windows gives us tremendous benefits as well as additional hazards. Most NWS offices have very small windows in very remote areas. There are very few windows in the operations area. We're unique in that regard. We have windows throughout the operations area, and they're very large. So if you have some sort of a severe thunderstorm approaching from the west, that does present a safety risk. We have 3 workstations where the where the forecaster is facing the windows. So if there's a severe thunderstorm heading in your direction, those windows could break and affect operations more easily than they would in most forecast offices.
Even if the tornado didn't affect us directly, my concern was that even the inflow or the outflow winds could be enough to break the glass.
Generally what happens is the forecaster in charge of the shift, or the event coordinator, the person who's kind of overseeing the operations of the event, makes a call, decides how close is the storm that we're concerned about going to pass near the office.
We drill for that. We also have a plan. We have another office that's our primary backup office, which is Jackson, Mississippi. We had been in contact with that office on and off during the day because of the severity of the event, and they were ready to take over at a moment's notice.
The coordinator will say, okay, everyone needs to go to the break room. At that point, they will call our backup office in Jackson, Mississippi, and they will say, we're evacuating, we need you to take over for us. And the Jackson office, the way our software is configured, the Jackson office can basically pick up right where we left off. They should be able to issue follow-up statements, issue warnings as if nothing has changed. The break room is a hardened room so that if this building is struck by a tornado, then it's a relatively safe place, comparatively speaking.
That's the first time I've been here 6 years that we've ever evacuated operations. The one and only time since I've been here.
We had several folks sitting in the break room hitting refresh on their cell phones furiously. That's literally what it boiled down to. You had folks visiting the National Weather Service webpage or using some sort of radar software or something like that. You often stay in there until the next volume scan of the radar comes in and you look and you see the rotations east of you or something like that.
That's what I remember. The feeling, it was just very, almost like we were going through a drill. To me, it was like, it wasn't real.
We came back out and resumed operations. I think the total time was like 8 minutes, perhaps. It wasn't very long, but one thing about it is we're no good to anyone if we're not safe.
For our area, North Alabama, from 3 o'clock in the morning until 9 o'clock at night, we were pretty much in morning mode. We had 18 hours with really no break.
We have learned, like, from storms that you either have flooding or you have severe weather. You usually don't get both. This one did both, and it did both on a high scale.
Obviously, it was a high impact event, and I don't know. I haven't counted exactly. I probably issued somewhere in the neighborhood of 35 to 40 tornado warnings that day. I don't know the final tally. I'd never care to work and issue that many again in a single sitting.
We were continually in morning mode. We didn't have a little rest to sort of recoup a little bit and see what had happened before we, it was like one wave, then another wave, then of course. So the two waves that hit in the early morning and the midday was nothing compared to what hit us in the afternoon and evening. And we were still reeling, though, from the early morning stuff.